and introduce to you our new double degree to meet this trend. In the new economy, there's a coming together of the accounting and data science AI fields. Many forms of media have reported this trend. For example, The Accounting Today, a trade magazine serving the public accountants in the US, highlighted a talk by the IBM's Chief Technology Officer, Katz Nelson, at a CPA conference. Katz Nelson said that the accounting profession offers the skills that businesses need, and that a data scientist needs a deep knowledge of a business. This strong demand for graduates with skill sets in accounting and data science AI have been shown also in these articles from the Journal of Accountancy and the International Federation of Accountants, IFAC in short. They pointed to the massive job opportunities for a person with data science and accounting knowledge. It's a home run in the profession for someone with these two abilities, writes the Journal of Accountancy, the flagship publication of the American Institute of the CPAs. The IFAC highlighted that the digital and data revolution offers massive opportunities for finance functions and exciting career options for accounting professionals. This trend is also happening on the local front. Hayes, an international recruitment agency, said that candidates with a hybrid of experiences, such as both financial accounting and analysis, are highly coveted, as finance team members are expected to wear two hats in their roles. There are various initiatives to accelerate the growth of Singapore's digital economy, such as the Accountancy Industry Digital Plan, the National AI Strategy, and also the NBS rollout of digital bank licenses. CNBC reported that finance jobs requiring AI skills increased by 60% last year. The finance industry is banking on AI with the creation of new jobs to bridge the gap. As shown here, the starting salary in the year 2020, last year, for NTU graduates with double degree in business and computer science is attractive, with an average of $5,537 gross monthly salary. The next two slides show how AI are being applied in the fields of finance and accounting. For example, machine learning is used to carry out cash reconciliations, intercompany reconciliations, and performance forecasting. Robotic process automation is used to streamline finance transaction processing. Virtual agents are used in payment term rationalization for procurement to payment (PTP) and order to cash (OTC) processes. Computer vision is used in real-time inventory accounting. Speech recognition is used to support finance help desk. Text analysis is used for automated contract management. This development of accounting technologies is a growth area. Startups in this area include Tiger, Staple, BlueMat, Notorum, Zev, Blackline, and Innovo42. These are just some examples. Xero is an established accounting system vendor which also applies the machine learning and AI in the products they sell. These technologies are smart and can extract, read, and interpret contracts, digitize invoices, assist in inventory management, bank reconciliations, automate onboarding processes, financial close processes, secretarial workflows, HR and payroll processes, among others. There is strong industry interest in employing graduates from the new double degree in accountancy and DSAI. For example, EY Singapore said that graduates will be highly sought after by employers, given the powerful combination of two key disciplines which are highly integrated in the work of today and tomorrow. C Group said employability will be high for this group of graduates, given that data-related skill sets seem to be high in demand in recent years, and accountancy is a profession that people sought after. DFS Venture Singapore also sends the same message. Next, let me give you a brief introduction to this new double degree program that is going to meet this trend. It will be a 4.5 years program that combines the 3-year Bachelor of Accountancy and the 4-year Bachelor of Science in Data Science and Artificial Intelligence (AI) degree programs. The program will have a manageable workload of 5 to 6 courses per semester and also includes a semester-long or 6 months professional internship. There will be opportunities for students to engage in cross-disciplinary learning, including a final year project with practical applications in the industry. There's going to be a new case-based course jointly taught by faculty members from both the business and the computer science schools. Graduates from this program will have the flexibility to join large accounting firms, financial institutions, consulting firms, commercial finance functions, and technology firms. More importantly, we hope to see graduates fill roles that require a blend of accounting business and data science skills in all sectors of the economy. The DSAI degree is a 4-year program that equips students with a strong foundation in data management and data modeling skills. The DSAI degree has been ranked by Forbes as one of the top 3 data science undergraduate degree programs in the world. Specifically, students will read core courses in computer science and data management, such as computational thinking, programming languages, data structures, data mining, AI, and machine learning. They will also read core courses in mathematics and data modeling that include calculus, discrete mathematics, linear algebra, probability and statistics, optimization, and regression analysis. As with all degree programs in NTU, students will also have to read courses and undertake internship programs to develop their professional skills to be workforce ready. There's also strong emphasis on holistic development, where students come together from all disciplines to interact in courses that examine societal issues such as ethics, healthy living, and sustainability. Our Bachelor of Accountancy is a very established and high-quality 3-year direct honors program. It covers core accounting and business courses. Core accounting courses include financial reporting, accounting for decision-making, financial analysis and valuation, taxation, auditing and assurance, and risk management. The program has placed strong emphasis on equipping students with digital and data analytics skills. It is because of the existing overlap in terms of courses related to digital skills, professional and holistic development that we are able to combine both degree programs and still allow students to graduate in just 4.5 years. Graduates from the double degree program will be well equipped in terms of being workforce ready. They will have overlapping knowledge and skills in the areas of data management, data modeling, accounting, and business. These students serve as a bridge between the tech and business functions in any organizations. The differential key skill they have will be their ability to utilize digital technologies in the context of preparing and analyzing accounting and business information for the purposes of governing, leading, and transforming organizations. A final note, accounting and data science AI are 2 sectors with strong emphasis for graduates in these 2 areas. There's growing emphasis by employers for interdisciplinary skill sets. Accounting and data science AI offer a powerful combination of skill sets well sought after by employers. Graduates with the double degree can operate seamlessly between the worlds of business accounting and technologies data science. This new double degree offers opportunities to enhance income and create job opportunities in this new economy and in a world with greater uncertainties. I thank you for your time. Next, I will hand off to Vincent. He is a third-year DSAI student. He will share with you more on the DSAI degree. Thank you.
All right, thank you so much, Dr. Lim. My name is Vincent, and it is really a pleasure for me to be able to share with you a bit more about the data science and AI aspect of the accountancy and DSAI double degree program. So before I start, allow me to introduce myself. My name is Vincent. I'm currently a year 3 undergraduate studying DSAI, minus the accountancy part, but I'm also taking up a minor in business. Currently, I'm an intern, a data science intern at Shopee. So my educational background was that I came from JC, and so as I was preparing for this sharing, I kind of remembered the days when I just graduated from JC. At that time, I was confused, I didn't know what course to choose, and I stumbled upon this course, the data science and AI course. But at that time, I wasn't very sure about what data science is about. Is it about, opening up Microsoft Excel, playing with numbers? Does that make you a data scientist? So I thought to start off today's sharing, I want to start with this question. What is data science? And to put things simply, I think data science is the art and science of transforming data into insights. Why do I say that it's a science? Well, it's because there are established ways to do certain things, like how do you model data, how do you process data. But at the same time, it's also an art because sometimes you need creativity to tackle problems, and also how do you present your data, how do you develop a solution to solve different problems. So although the name data science only has the word science in it, I do think that it's both an art and science. And what does all this definition mean, right? So let me give you an example of what data science is all about. And the example that I want to use right now is autonomous vehicle. You might have seen it a lot in movies. I'm not sure if you have seen it in real life, but I just want to let you know that on the top left of my slides, you see this autonomous bus. And 2 years ago, it was actually approved to be tested in actual traffic conditions. This is an autonomous bus built by NTU, LTA, and Volvo. And it is really cool to see that something I see a lot in movies is being tested in my very own campus. I actually saw it with my own eyes earlier this week. They tested it in front of my hall, so I thought it was really cool. And on the right, you see something called a food bot. And I was ordering bubble tea on this application called Kate's, and to my surprise, they actually delivered the bubble tea to me using this food delivery robot. It's a self-driving robot which delivers food around NTU. So this is another example of an application of this autonomous vehicle. And I think now it begs the question, right? Like, why is this considered data science? Earlier, I talked about this transforming data into insights. Well, where's the data in this, right? So if you're talking about autonomous vehicles, you need data as input. Let's say you have an autonomous vehicle. You want to know how far is the vehicle from the vehicle in front. Is there anything to its left or to its right? Is the road slippery? And what's the color of the traffic light? So these are the kind of data that you take as input through the sensors of the vehicle, let's say. And what kind of insights do you make from this? The decision that the vehicle needs to make. Should it continue moving forward? Should it turn left? Should it turn right? So the idea of transforming data into insights is something that you'll do a lot in this data science and AI program. And with this, I hope it has given you a better understanding of what data science is about. And now let me tell you a bit more about how the NTU curriculum prepares you to be a data scientist. There are two important pillars in the DSAI program, which is the computer science and mathematics aspect. The computer science is taught by the School of Computer Science and Engineering, and the math part is taught by the School of Physical and Mathematical Sciences. And through strong grounding in these two aspects, you have a very good foundation in these two aspects, and you'll get plenty of opportunities to apply what you have learned. So it's not just about studying all the theory, but you also get to apply it to things like, let's say, projects and competitions. Let me share with you a bit more. Like earlier this year, I actually participated in a competition. It's NUS Computer Vision Competition 2021. So the problem statement is about HP's manufacturing problem. So they have chip manufacturing, and they wanted participants to build a solution, a computer vision-based solution to count the number of chips in a given image. So in the past, they have papers of chips, and they need to count manually how many chips are there in a piece of paper. And imagine counting 300 pieces of chips on a piece of paper. And this has to be done manually, and it's also prone to make errors in this calculation. So people built this computer vision solution. It makes things faster, more efficient, and you make less errors through this computer vision solution. And different teams came up with different solutions. I'm not trying to brag right here, but my team actually came in first place for the competition. So I think this also shows the amount of training that NTU will provide you through this program. And the next part where you get to apply the program is also through industrial exposure. Currently, I'm an intern, a data science intern at Shopee, as I've mentioned previously. And last year, I was also a data engineer intern at AMD, which is a semiconductor company. And through these experiences, you get to see how data science is being applied in the industry, outside of the classroom. And you'll be surprised to see that actually in different industries, they do things differently based on how it's being done in the specific industry. So this is the kind of exposure that you'll get, which will enrich your learning experience. So this is about the DSAI curriculum. And so far, I've been talking a lot about the mathematics and computer science. And indeed, these are two very important aspects to make you a very good data scientist. But there is one thing, the third component, which I feel is very important for you to be a good data scientist. Do you want to take a guess on what this is? Okay, I can't exactly hear your responses because this is a virtual event, so let me just reveal the answer to you. The third component, which I think is important, is domain knowledge. Domain knowledge. And you might be wondering what this term means, but it basically means if you want to apply data science in a specific context, a specific industry, specific domain, like let's say now I'm working in an e-commerce industry, you actually need to know how the industry works and how the domain operates before you can apply your data science techniques. There are many fields where you can apply data science. For example, accounting, economics, manufacturing, physics. And I think one of the fastest growing fields is accountancy. And I think Dr. Lim earlier has given lots and lots of good examples of how you can put data science and accountancy together. And now I want to zoom more into this accountancy part. And I think as a double degree accountancy and DSAI student, you encounter this type of problem a lot, which is called the forecasting problem. And I know it's a technical jargon to use forecasting, but it simply means predicting the future. And it sort of makes you feel like you're a fortune teller trying to see what's in the future, but it is something that we do pretty much on a daily basis, like let's say predicting your weather forecasting. Is it going to rain tomorrow? And when you leave your house and you check your phone battery level, 50%, will it last you to the end of the day? So this is the kind of forecasting that you do on a daily basis. And in the accounting case, let's say you're in charge of inventory. You are selling products and you want to place orders for the next month to make sure that you have enough supplies to meet your customers' demand. And it is important for you to predict the demand from customers accurately because let's say you overorder your inventory. Then you would need to bear with the extra storage costs. And if it's perishable, then the things will expire. But at the same time, you also cannot underorder, because if you underorder, then you won't meet the demands of your customers. So it's important for you to forecast well. And using this forecasting example, I would like to give you a taste of what it is like to think like a data scientist. And some concepts which you might actually encounter when you take up this program, the double degree accountancy and DSAI program. And to illustrate this forecasting problem, I'd like to take a competition problem, which is launched by AI for Impact last year, which is called wind energy forecasting problem. So they have this data about wind energy being produced in France from the past few years, let's say. And the problem statement was, can you predict the wind energy production 18 hours from now? And to put things into perspective, now it's about 2 p.m., right? So it's like predicting what will be the wind energy output tomorrow, 8 a.m. kind of thing. So can you predict the wind energy output tomorrow, 8 a.m.? So that's the problem statement. And so how do you tackle a problem like this? As a data scientist, you'll look at 3 different aspects: data, modeling, and prediction. So let's take a look at data. So data. What kind of data do you think would be useful for this kind of prediction? Earlier, I said we had data about the wind energy production from the past few years, so that could potentially be useful. Can you find any trend from it? Are there any patterns? That is one data. And are there other important data that could be useful? Maybe you tell yourself, if I want to predict wind energy, then information about wind speed, wind direction could potentially be useful. So this kind of data you would collect, possibly through the wind energy farm themselves, or maybe through the internet, through APIs or websites where you can download this kind of data. And this will probably come in the form of numbers, or maybe Excel files, who knows. And what do you do after that with all this data? So data scientists really love to do this thing which is called data visualization, which is another jargon or technical term to say, how about we draw charts, plots, graphs to see what's going on? So on the slides, I have actually plotted the wind energy and wind speed against time. And through this kind of visualization, you might observe a few things. And these observations help you understand the data better. Have you observed anything from this visualization? So if you take a look, it seems like both wind energy and wind speed seems to be fluctuating up and down, right? It goes up, goes down, goes up, goes down. And you start to suspect, it seems like there is a regular pattern to this. It seems to happen every few hours. And so you look into the data closer, you do data analysis, and then you figure out, this regular pattern seems to happen every 24 hours. And this is your hypothesis. So a hypothesis is that wind energy and wind speed has this fluctuating pattern every 24 hours. And how do you prove that your hypothesis is true? You do hypothesis testing, which is something you might have encountered in high school or JC. There's this hypothesis testing chapter. So this is where it comes in. Can you prove that your regular pattern happens every 24 hours? And if it indeed is true, how do you explain what's going on? And this is where your domain knowledge comes in. Maybe you can explain in such a way that, it seems like the wind blows stronger at night compared to during the day. So, or should it be the other way around? I don't know. I think that's where the domain knowledge comes in, right? To explain what's going on with the data. And through this process of observing, analyzing, and explaining, you get a better idea of your data, which would be useful for the next phase, which is called the modeling phase. Now, modeling. How do you create a model to predict your wind energy 18 hours from now, based on what you saw in the data? There are different techniques that you could try. For example, is like persistence. Persistence simply means maybe I use the value for now. Let's say now the wind energy output is 40,000 kilowatt hours. Would this be a good prediction for tomorrow, 8 a.m.? Possibly. Or maybe you take the mean. Maybe I take the average of the past 24 hours and take it as my prediction for 18 hours from now. Or you could also do a regression. Regression is a term to say, how about we do like a best fit line? Y equals mx plus c. If I make my x as wind speed, can I predict y, the wind energy? And would it be a good enough model? Will the points be close to the best fit line? So these are different statistical models which you could consider. But one thing about these statistical models is that you need to specify how you want to do it. Do y equals mx plus c. Take the mean. So recently, people have been moving away from this kind of models and developed this approach called machine learning. I'm sorry for using a lot of technical jargons today, but I'm pretty sure you have heard this word machine learning. It was even featured in a Korean drama recently called Startup. Okay, let's not go there, but yeah. And let me explain to you a bit more about what machine learning is about. It literally means what the name says, machine learning. So instead of telling your machine what to do, how about we make the machine learn? from data. So instead of telling the machine what to do, you tell the machine, I'm going to give you data, you figure out on your own what's the pattern and how to do things, and you learn from the data. And the machine, instead of telling the machine what to do, you give it the capability to learn and to figure out patterns. And that is the idea of machine learning. And I think this mimics how humans learn as well. Let's say you have a child trying to learn how to distinguish a cat and a dog. You don't tell the child to measure the tail and measure how many cm is it. If it's more than, let's say, 5 cm, and if the ears are pointed, then it is considered a cat. You don't give rules like that. But instead, how do you teach the child? You give examples of cats and dogs. You tell the child, this is a cat, this is a dog. And through this idea of learning through examples, I think this is the spirit of machine learning. And this is something that you'll encounter as well in this data science and AI program, machine learning. And through all this modeling phase, I think now you can go to the prediction part. Prediction means making a prediction from the model that you have built so far. So this is an example of a prediction which is made using a machine learning model called neural network. And the blue lines show the actual wind energy output, and the red lines are the predicted wind energy output. So do you think this is a good or bad prediction? What do you think? And so to answer this question, I would like to use a phrase which data scientists really love to use. It depends. It depends on what, right? Depends on what. So it depends on how you define good or bad. It is, good or bad is subjective. So how do you define good or bad? Is it when you compare this neural network model against something simple like the persistence model and it makes less errors? Will you consider that to be good? Or do you want to go one step further and run simulations and see whether you can earn money from your model? And if you indeed can earn money using your model, your data science solution, then you have created a data science solution which can potentially deliver business value to the company and possibly even improve society as a whole. So with that, I hope I've given you a taste of what it's like to think like a data scientist. And I hope you'll consider the double degree accountancy and DS AI program. And I'm excited to see the things that all of you will get to build when you join this course to deliver business value or to improve society as a whole. So thank you so much. And now I'll pass my time to Kai Chin, who will tell you a bit more about the accountancy part of the double degree program. Thank you so much.
Hi, how's everybody doing? Right, today I want to talk about just 3 things, okay? I want to share a little bit about my experience in NBS. After that, I want to talk a little bit about how my peers are doing and where they're going. And lastly, I want to share some of the things I've seen about the intersection of business and analytics. So let me start by sharing a bit about myself. I am a year 4 accounting and business analytics student. And over the past 4 years, I've been taking both accounting mods and analytics mods. Now, what does that mean? What is accounting? Well, to me, accounting is the language of business. So how do you compare whether this business is doing better than that one? Or whether the business has improved or gotten worse over time? How do we find where the problems are and how do we fix those problems? So this is, in essence, what I think accounting is. It's the language by which we articulate and we compare these things. So there are many modules in accounting that we've taken. I've put some of the broad categories of modules here. You have financial accounting, management accounting, tax, and also you take some of the business fundamentals courses like HR, marketing, etc., etc. So putting everything together, you don't just get a technical knowledge of accounting and financial reporting. What you get is really how do you understand the essence of a business and how a business works and functions? How do you compare businesses? And how do you find the places where you can make businesses better, more efficient, and more profitable? Now, that's the gist of accounting to me. Now, in addition to my accounting degree, I've also taken a degree in business, where I major in analytics. Now, I've put, again, some of the core modules here on the screen. Broadly speaking, I think, and I'm grouping them very broadly here, there are core programming modules, just like R and Python. You learn the basics of how do you write simple code. You learn a bit about databases and predictive analytics. So how do you build a database? How do you query data? How do you build predictive models? And you take a couple modules about analytics in practice. So in specific domains like supply chain analytics, financial services analytics, In these specific industries and domains, how is analytics put into practice? So the thing about accounting and business analytics is between these two degrees, they've given me the expertise and the knowledge to take on quite a number of internships over the past 4 years. So I've put some of the internships I've done on the right. Broadly speaking, there's a few categories. I've done consulting work with Bain and Kearney. I've done finance work with CVC, with Mazars and Reciprocus. Mainly, I did private equity, investment banking, stuff like that. I did a bit of data analytics work with Shopee. I did capital raising with Glintz. So I helped them raise their Series C venture capital. And I've also done some social work. Skills for Good is something I founded with my friends. We help to promote skills-based volunteering in Singapore. And we've reached out to over 30 clients and about 100 plus 200 volunteers right now. Career Socials is also a social enterprise that was set up by a couple of seniors, and I've worked to help them deliver social impact. So one thing that I wanted to highlight is why business analytics? Why do I think it made sense to take business analytics in NBS? And to me, I think it comes down to 2 points. One, business analytics is a future-ready skill. It's broadly applicable across all industries, across all functional areas. And it's something that prepares you for the explosion of data as you move forward. And the second thing is, I find it's difficult to get good accreditation for business analytics skills. Like for finance, you can take CFA, or you can take Chartered Accountant, ACCA stuff if you want to do accounting. But for business analytics, it's very hard to find a good accreditation for it. So I feel like a business analytics degree or a data science degree is a perfect way for you to get the skills and get the accreditation you want. So moving on from the professional and academic life, I'm going to talk a little bit about my student life. So over the past 4 years, I managed to get to quite a bit of traveling right before COVID hit and all the traveling came to an end. 3 main buckets of travel. The first one is representing NBS overseas. I've represented NBS in Canada, in Japan, and also in Thailand. So I've done a range of case competitions covering everything from how do you grow an insurance company to enter new market segments, to how do you help a pension fund manage its portfolio, and also manage an aging population. So over the past couple of years, I've won, I think, 8 case competition awards in Singapore, Thailand, Canada, and Japan. And it's all thanks to NBS, who partially funded my travels. So very thankful to them for that. Now, in addition to representing NBS overseas, I've also managed to travel overseas for work. So I've been to Macau, and I've also been to Jakarta. The picture here is actually me and my friends in Macau. Very, very fun trip. And I went to Jakarta also to work in my year 2 summer. I was working on this telecommunications, media, and technology company in Indonesia. And I traveled to Jakarta every week. So I would fly out on Monday, 7 a.m. I'll get back on Friday, 9 p.m. And then I'll stay in the hotels in Indonesia for the entire week. So I flew in and out for maybe 3 or 4 months. And it was a great experience. And it was very exciting, very, very interesting for me. And I learned a lot during the experience. So working overseas, the second bucket of travel. Now the third one is exchange. Now exchange is some of my happiest, most beautiful time in my life. I went there, I think, about a year ago now, a year and a half ago. I went to Europe. I stayed in Milan, Italy. And I got to travel to more than 8 countries around the European area. The picture here is actually from France, in Toulouse. And not only do you get to study in overseas universities to see how they teach and what the culture is like, and how students over there learn and how they behave, but also it's really just a great, super enjoyable time. And I can't recommend it enough. So moving on from student life, one more thing I wanted to share about is my internships. So I've called out specifically my internship at Bain, which I worked at last summer. And I did 2 main projects there. The first one is developing a referral model for a private hospital group in Southeast Asia. So the business question here is, how do you get doctors or general practitioners to refer more patients to the private hospital group? How do you increase the volume of patients that come to this hospital? So this was the question that they gave us to work on. And how business analytics helped here is that I managed to do a geo-mapping of the patients and doctors cut by specialties across the different towns in that particular country in Southeast Asia. I can't say where and I can't say who because of confidentiality reasons, but I got to see across different geographies, right, what the trends were like, and which doctors can we best target, and which types of patients can we best target to increase the patient flow to the hospital. So this was one piece of the project that I was given ownership of, specifically because I had the business analytics capabilities that NBS taught me. Of course, there were other pieces of the projects more towards the traditional kind of business work, identifying doctors to target, developing good pricing models, et cetera. But this piece specifically was given to me because of my business analytics major. So the second project that I worked on was a commercial due diligence of a retail company in Malaysia. So this was a beverage company that operates in Malaysia. And the question that was given to us was, should this company buy over this beverage company with the view of holding on to it for 5 years and selling it 5 years later to turn a profit? So is this a good idea? Are we likely to make profit if we buy this company now at a certain valuation and we sell it later? So I worked on this case also, and the specific piece that I got to work on, again because of my analytics training, is web scraping and sentiment analysis of all mentions of the company's product. So look on Twitter, look on forums, look on Facebook. Who has been talking about this brand? What have they been saying? Is what they're saying broadly positive or negative? What kind of themes come up very often? So based on this, you can get a sense of how customers feel about this brand. Is it a quality brand? Are there red flags that we should be aware of? So this supplements a more traditional business approach where we do a customer survey and we did taste tests. So we got a bunch of people to come in and sit down and drink the beverage and comment on whether it tastes fresher or better or sweeter than the other competing products. At the same time, we can also look at the survey results and see whether the product outperforms other competitors in various categories. So again, the business analytics skill set here complemented a more traditional business approach, and it gave me a unique piece that I could work on, that I could take ownership of, again, because of this business analytics training. So broadly, what I've seen here in my Bain internship showed me that even in traditional business roles, and management consulting is a pretty traditional business role, there is an increasing use of analytics to complement traditional business approaches, so you can validate the results and see if we arrive at similar conclusions. And also, if you have a business analytics training compared to a more general kind of business experience, you get to take ownership of pieces that are unique to you, that only you can work on. And this allows you to stand out. This allows you to have face time with the superiors and the seniors. And it allows you to overall perform better in your internship and your work. So I think that the business analytics training allowed me to perform better in this particular internship. And I secured a return offer for September of this year. So I'll be joining Bain in a couple of months when I graduate. So on to the second thing I want to talk about. So that's everything about sharing about my experiences. Now I want to talk a little bit about my peers and how other accounting students are doing. So one thing I noticed in my internships is people tend to say that NTU accounting students have really good technical skills. So that their accounting technicals are really solid. That's something I've heard like a couple of times across multiple companies. And I think this propels NBS accounting students to go on to various exciting careers. And I've put a couple of categories to them on the right. So not only do we do traditional accounting roles, so you have audit, tax, commercial accounting, you also have various finance roles, front office, back office. You also have various commercial business roles, consulting, sales, marketing, HR, etc. So this is strictly non-exhaustive. It's just some of the things that I could remember top of my mind. But accounting technicals do help with a wide variety of roles, not just in accounting, but also in business. Again, to me, accounting is really the language and the lifeblood of businesses. And it prepares you for a wide variety of business roles. So the last thing I want to talk about today is I want to share some of the things I've learned about in my various internship experiences, about the intersection of business and analytics. So in my experience, over the couple of internships, I realized that having a combination of business and technical knowledge helps with many roles across many industries. So broadly speaking, you can say that there's convergence between technical roles and business roles. Business roles increasingly could benefit from some technical expertise, but technical roles could also benefit from increased domain knowledge. So that's one thing I noticed. So when I was at Shopee and I was working as a data analytics intern, so this is more towards a technical role, the hiring manager was actually looking for both business acumen and technical know-how. So you needed to understand some domain knowledge about how the business works. Specifically, I was working in logistics and supply chain optimization. So you have to understand how a supply chain works. You have to understand how the logistics and delivery works, how the app works, and what customers are looking for. So in Bain, like I mentioned earlier, it's a traditional business role, But again, you could benefit from understanding a little bit about analytics. And this will allow you to stand out compared to your peers. Lastly, one more example I put here was Mazars. This was some time ago when I interned there doing financial due diligence. So financial due diligence is analyzing a company to see it's worth buying from a financial perspective. So do the accounts look, does the profitability look replicable? Do the quality of assets look good? So that's financial due diligence. So the BA knowledge here allowed me to develop a suite of VBA programs to automate some pretty basic and manual processes, like cobbling together separate management accounting files into a single database. From there, we can produce our own P&L and our own financial statements. So again, here, a technical knowledge helps to complement traditional finance business accounting skills and give you something that allows you to stand out compared to your peers. So I think these things combined together show you that business roles increasingly need knowledge of analytics, and technical roles can definitely benefit from some domain knowledge as well. And I think that these things help you stand out in the job. It helps you stand out in finding jobs and performing well in your job. And then it brings me to the right side of this slide, right? This dual expertise is something that we find that employers are willing to pay for. Over here, I've put a chart that tells you the median gross salary by degree and by specialization. On the left, you have computer science that comes in at 4.558. And we see that if you go into a double degree of accounting and business analytics, and accounting and business and computer science, you see a 7 to 21% increase in salary. And I think that this is really driven by the fact that employers do value this dual expertise. And that's something that I want to close on today. I think that there's a lot of value in understanding both business acumen, accounting, and also technical analytics, computer science skills. I think the market is responding strongly to this, both in terms of what hiring managers are saying, and also in terms of financial incentives, which are increasingly reflecting this reality. And so that's where I want to leave you today. I think that this double degree is something that is really valuable. It's something I would consider taking if I was year one all over again. But this is something you should think very strongly about, and you should consider taking this degree. Thank you.
Thank you, Kai-Jin. Good afternoon. I'm Associate Professor Dong, and I'm the head of accounting at the Nanyang Business School. So I'll be your moderator today for this panel discussion. And my goal is to have the panelists answer and share their thoughts on any questions that you might have about a double degree in accountancy and data science. So please post your question on Slido, and we will attempt to go through as many of them as possible within the next 45 minutes. So let me briefly introduce our panelists, of whom the first three you have already heard from. We have Dr. Lim Chu Yong, who is an accounting professor at the Nanyang Business School, and is also the school's program coordinator for the double degree program. We also have Mr. Vincent Ripley, who is a third-year DSAI student, as well as Mr. Chow Kai-Jin, who is a fourth-year double degree accountancy and business student. And we also have our fourth panelist, Dr. Suresh Gupta, who is an expert in data science and AI, and teaches these topics at the School of Computer Science and Engineering at the NTU. Since we have not heard from Dr. Gupta yet, shall we begin the panel discussion by having him share his perspectives on why a student should study DSAI and what advantages a graduate might have in the digital economy if he's equipped with both accountancy and DSAI skills. Suresh?
Thank you very much, Prof. Tong. So, hello, everyone. I believe I'm looking at the right camera. Hello. So, welcome to the session, and I'm glad that you could join us today. So, if you have any questions about the double degree program in accountancy and DSAI, we are here to answer all of your questions today. You have already heard from Dr. Lim, you have heard from Vincent, you have heard from Kai-Jin. I doubt I can add much more to that because they have already covered a huge spectrum why accountancy and DSAI really work hand in hand. let me still share a few pieces of information which you might find useful. So when we talk about data science, we talk about AI. It used to be a very core computer science or computer engineering discipline because we thought about it from a core technical point of view. You need a lot of computing skills to go into this area. You need a lot of muscle in terms of computing power, in terms of programming knowledge, and so on. But now, when this has become quite commonplace, if I may say so, in a lot of businesses around the world, we tend to see the other side happening. Quite early, maybe a few decades earlier, you would form a hypothesis, you would think of a problem first, and then you would go out in the market to collect data. You would collect the data, you would form your hypothesis, and you will test it against the data you've collected. Kaijin mentioned a point about it as well. It's surveying, and we used to do that quite often. That would be more of a core domain of analytics from a statistics point of view. But now, data is probably one of the cheapest and easiest things to get. Even though we say data is the new oil, so of course, it's extremely valuable, but in the raw sense of data, it's really, really simple to get. So Kaijin's example, web scraping for sentiment analysis could get you a lot of data quite fast. You don't have to do a survey, which is painstaking and quite time and effort consuming. Once you have this data, then why do we say data is so valuable? It's valuable not only in its raw form. You have to analyze it. You need to know how to extract insights from it, as Vincent mentioned earlier. And then you talked about models. You talked about how to extract insight from data. And once you get the insight, who validates what the insight is? That would be you, the domain expert. The person who knows the domain so well that you know whether that insight that came out of the data is really applicable to your business, to your case, or to the organization that you're working for. If I remove you from the picture, the domain expert, then just the data or just the analysis has no value. So there is where I believe something like an accountancy and DSA, a double degree, comes in the most. We need so many people in this area of accountancy who doesn't just get data and get somebody else analyze it, but they know how to gather insight out of it themselves, and they also know how to put their judgment on those insights to make it even more valuable. So that's where I believe data science really flourishes. Machine learning techniques like what Dr. Lim said, computer vision, text analytics, AI, of course, for optimization and other areas of multi-agent systems are coming in more and more. But unless it's driven by a problem definition from your domain, which you have formulated, most likely, and unless it's backed up by insights that you have gained for your own domain, just data science doesn't make sense. That's the entire pipeline. And I believe in accountancy, in business, in finance, any of these areas, data science is not going to be a tool that you wish you had. You have to have it. It's becoming essential day by day. You need to look through the data that you've gathered. Quite often, it's so massive and it's so diverse that it's very hard for you to even look at the data unless you know a bunch of computing skills. That's where DSAI comes in, and that's why it pads up with accountancy. So that's my thought on it. You need it. It's not really something good to have. It's a need of the hour. It should be together, and it is. You have the option of going for the double degree, right?
Thank you, Dr. Sharif. Laying out the strong demand for talents that are able to harness the knowledge and skills in both data science and accounting and business. We have some questions from the audience. Some students are wondering, since they have not taken any computing or accounting courses before, will they be a disadvantage coming into this program? So basically the question also relates to what kind of students will do well in this double degree program. Perhaps Dr. Lim would like to share with us first on this.
Okay, so let me first share on the accounting side, because typically many, or I would say actually most accounting students coming from the JC, junior colleges, they do not have prior knowledge in accounting. And most of them, the vast majority of them, actually go on to do well. Why? Because accounting is something that is built on analytical skills, and you need good language skills as well. And so the junior colleges, whatever you learn, whether in mathematics or even in sciences, that build you up in these areas, analytical skills and language skills, actually do prepare you well for accounting. Of course, there are some students who may have some prior knowledge in accounting, and when they enter, say, the accountancy program in year 1, the intro to financial accounting course, they may have a bit of head start, yes. But thereafter, most students are really on par thereafter, I would say.
Thank you, Dr. Lim. Kai Jin, would you like to share from your perspective as someone who is doing a double degree in accounting and business? Do you have any accounting background before coming to the program?
No, I didn't have any accounting background. I came from a JC also. Never touched accounting before in my life. I was a science student. I took physics, I took chemistry, math, economics. Never in my life accounting. The last thing I did was Sadia and Senang Diri in Parade Squares. So when I came into this, right, accounting was super new to me. I had no background whatsoever. But I think one thing that I can say is the early accounting mods, especially the early accounting mods, are super well designed. And it's really easy for you to follow even without any background. So that's one thing that I think the school has done an amazing job on. The Accounting 1 and Accounting 2, the early accounting modules are really well designed. And I don't think that you will have a lot of difficulty picking up accounting from ground zero. And I also don't think you'll be significantly disadvantaged compared to those with prior accounting background. Because at the end, they guide you really well through the learning process. For data analytics, I would say that the pickup is a little bit more difficult. It's not so much hand-holding, it's a very complex subject matter. So without some coding experience, it might be a little bit more difficult. But I'll leave it to Vincent to talk about that, right? I think you have much better ability to share about this. But on my part, I still felt it was super doable. It's very possible to do it even without any background. So I wouldn't be worried at all, even if I didn't have any experience coming to this. Thank
you, Haijin. Yeah, so let's turn the question over to Vincent and Dr. Suref. So in terms of DSAI, do students coming in really need knowledge of computing, programming? And in fact, we have another related question is, how much math do I need to know coming into the DSAI program?
Okay, so maybe let me start first. So as for my background, I also came from JC. So I had no background whatsoever in programming or coding. And all I knew is that I love math. And I thought this course was exciting because, well, you get to turn math, all those numbers, into applications you see daily, like speech recognition, classification of images, and to see numbers being transformed into these kind of applications was exciting to me, and that's why I joined the course, purely because I like math. And for programming itself, I don't have any programming background at all. I came in not knowing what Python was and whatsoever, but I think not to worry. Most of the people who join DSAI program do not have any programming background at all. And in fact, in the first semester, you'll have this introduction to computational thinking and programming course, where you learn to think, how do you think like a computer scientist? And you start from there, and the emphasis is for you to learn how to think, and then you learn how to express what you're thinking using a programming language. And I believe in NTU's teaching policy, they teach it in a way where the emphasis is not on the programming language itself, but how do you use these languages to express concepts? How do you build data science solutions using this programming language? So don't be scared if you don't have any programming background. But I must say though, for you to do well in this program, I think you should enjoy math. You'll keep on seeing math through all the semesters in this program, and you'll see a lot of mathematics. And so based on my experience, based on my friends and all, those who do well in this course and those who enjoy the course are people who love math, who genuinely love numbers, play with numbers, and to build things, explore possibilities using data science. So that's my response. Dr. Saraf?
All right, that's a good question actually. A lot of our students also ask, how much computing do I need to know beforehand? So let me put you at ease from a different perspective. So I'm from the School of Computer Science and Engineering, right? So we have our core 2 undergraduate program, which are computer science and computer engineering, bachelor's in that. Even for those, we don't expect you to have a computing background, all right? So not just for DSAI, we don't even expect you to have a prior programming knowledge, even for our Bachelor's of Computer Science and Engineering programs. So feel free to join, even if you don't know it. And as I'm going to steal a line from Kai-Chen, actually. He mentioned accountancy is a language for business. So programming is a language for computer science logic. It's a logic that you need to understand. Language will teach you, don't worry, okay?
Thank you. I just want to add something. We'll have a lot of accounting applicants into our program that often highlight the fact that they love math. That's why they want to come into accounting. So my understanding is we have a group of students that really love math, they want to come into accounting, and they will equally do well, I guess, in this double degree, because math is also something that they should have in order to excel in this double degree program. So thank you for responses for both 4 of you. Another set of questions relates to the difference between data science and AI versus computer science. So some audience are a little bit confused in terms of how different these 2 disciplines are. Perhaps Vincent and Dr. Suresh can quickly share with us the key differences between these 2 disciplines.
All right, so from my perspective, okay, so in the past, this data science program was just launched, or when I came into NTU, and in the past, we only had this computer science and computer engineering. Data science and AI are 2 specializations in the computer science and computer engineering program. And so this data science and AI program are just separate specializations of the computer science, data science, and AI specialization. And why is this course launched is because, well, we felt that if you do just computer science, people don't really have sufficient mathematical background to build advanced, to do more in data science and AI. So that's why this course is launched, where half of the courses are on computer science, mostly more on the algorithmic and the software parts, so not so much on the hardware parts. And then you put mathematics into the picture. So half of your curriculum will also be in mathematics. And so you get to specialize as early as your first year. If you take a computer science or computer engineering program, you only specialize in year 3 or year 4. But for this DSAI program, as early as year 1. And in my first year, actually, I already started working on machine learning projects with a course with Dr. Saurabh. We get to choose a problem that we want to solve, build, analyze data, then build models and make predictions using machine learning as early as year 1. So a benefit of specializing early as year 1 is that you get to build your portfolio, let's say, from year 1 onwards. And then let's say you want to choose internships in year 2, year 3, you already have relevant background for you to go for data science and AI internships. And I think that is why this course, Data Science AI, is launched a few years back. So yeah.
Right, thank you, Vincent. So yeah, I believe Vincent has already mentioned his motivation for coming into this program. If I may add to that, if you think about what is the difference between computer science, computer engineering to going into maybe data science and AI, think about the fundamental subjects as well when you're taking, say, science, and then you're taking math, physics, or chemistry. From that, suddenly you jump into computer science. Why so? Because you're applying the same mathematical logic and the same ideas, but in a very different context. It's a context of computer science. But computer science itself, by now, is quite a mature field and quite a broad field. You might go into more on theoretical computer science. You can go in more of, say, cybersecurity. You can go in machine learning, data science, AI, networks. You can even do distributed systems, blockchain, whatever you want. So being so broad, it does cater to the general audience. If you do not know which specialization you want, then you are more than welcome to join the basic computer science program and then choose later, maybe in year 3 or so. But data science and AI, as is a need of the hour, is extremely important as a specialization to start as early as you can. Hence the program. So data science and AI pushes you to go into this specific program as early as possible. So you can call it sort of a depth-first approach, right? You are going into that specialization. All right, how do I broaden out of it? That's where this double degree comes in. If you think that you are a data science expert, but you also want to have your other passion for math, going into business, going into accountancy, have that together. You're getting twice the amount of advantage out of such a double degree. Okay? So DSAI is there, but again, the domain knowledge, as I mentioned earlier, is extremely important. If you want to be a domain expert in accountancy, then there's nothing better than such kind of a double degree.
Right. Thank you, Vincent and Dr. Suref, for that insightful sharing. Another question, but I guess we'll have Dr. Lim answer this. What's the difference between accountancy with a minor in digitalization and data analytics versus this double degree, which combines DSAI and accountancy? Is it one necessarily better than the other? And is it that job prospects for one will be better than the other? So these are the questions that came up with this.
Okay, so the double degree is a matter of depth. That means the DSAI allows you, as shared by Vincent and Dr. Suref, that actually it opens up new fields on data management, data modeling, mathematics, all these quantitative skills, which, yes, you can pick up some of them via the minor in business analytics that Kai-Jin has picked up. But over time, the employers are going to demand more. So the employers are going to say, look, we have people, someone with in-depth skills in accountancy and with DSAI double degree versus someone with minor in BA. So basically the job prospects, the job opportunities are very different. The areas that someone with a double degree can go into will be much more than a person with a minor in business analytics, I would say. Yeah.
Thank you, Dr. Lim. Kai-Jin, you're doing the business analytics as part of the business degree. So again, where do you see the differences between business analytics and data science and AI?
Well, I think Prof is right. It's a question of depth. How deep do you want to go? What are you trying to do with that knowledge, right? So on one hand, you have like the business intelligence and some less deep analytics work. On the other hand, you have data science or even like data engineering, and this goes really much deeper in terms of technicals. So it really depends on how deep you want to go. What are your career aspirations? What do you really want to learn from it? So I think when you take a business degree with a major in analytics, so I'm a double degree in accounting and business with a major in analytics, right? They teach you more of a focus on business, a focus on domain knowledge. For example, finance industry, how does it work? And then on top of that, they tell you, okay, so this is how analytics is applied to this industry. It's more business focused and business oriented. So at the same time, what you expect in terms of this exchange is also, you don't go as in-depth into something like data science, which is a little bit more deep and complicated. And it's something that we wouldn't touch so much in this degree. So again, I wouldn't say one is superior to the other. There are always a series of trade-offs depending on what you want to do. But each one unlocks a different career trajectory for you. And it really depends on what you think it is that you want out of your education. But regardless, I would still suggest some variety of a double degree program because I think this still offers you a wider range of skills rather than a single degree in data science or a single degree in accounting. So regardless, I would say you get a wider exposure and a more interesting view on things when you come out to work. But again, as to which double degree you want, it's a question of what are your objectives and what you want out of the degree.
Right. Thank you, Kai-Jin, for the excellent insight. Now, some of the question that comes in deals more with the structure of the double degree program. I guess it's also related to the depth, in the sense that the question asks, why do I need 4.5 years to complete a double degree? In fact, can I do it in less than 4.5 years? Or, if I cannot cope with the program, can I take more than 4.5 years to complete the program? So perhaps Dr. Lim, you want to share with us why did we structure this double degree into 4.5 years?
Yeah, because this is already to cover two technically rigorous degree programs. So if we look at the Bachelor of Accountancy by itself, it's a 3-year degree program. the Bachelor of Science in Data Science and AI is a 4-year degree program. So there are some overlapping courses in data analytic courses, professional development courses, holistic development, which we can count on both sides. And so that allows us sort of to pack it into 4.5 years. So our recommendation is for you to complete in 4.5 years. If you need time to complete, to extend beyond 4.5 years, that is allowed because we understand if you need more time, but there will be considerations on the funding and the subsidies. So that will have to be taken into account if you have to extend your study beyond the recommended 4.5 years. So in short, it is allowed, but we have to discuss further. We have to look further into how much more time you need and the additional cost.
Thank you, Dr. Lim. We have a very light-hearted question here. Are there more guys than girls doing DSAI? Perhaps
Should I answer?
Vincent or Dr. Surya can
probably
share some
Vincent's
insight on that.
question.
Okay. Yeah, so actually for my year, we have 24 students. It's actually quite balanced. We have 12 guys and 12 girls, so it's 50-50. So that is the gender ratio. I think, yeah, in such a field where you deal with numbers, I think there's equal interest from both guys and girls. That's why we have a balanced gender distribution in my cohort, yeah. And as far as I know, the batch below me, which is the second year, they have more girls than guys. So yeah, that's what's happening right now.
I was going to mention that. So your next batch, your first batch of DSAI used to be 24, roughly half and half. The next batch is around 53, 54, more girls. And then the current batch that I'm teaching right now is 73, which is, I guess, about balanced. So I think for the double degree, if it's returning NS men's and not coming, then this batch will probably have more girls.
Right. So because this is the first batch, and we probably have more girls than guys in this new double degree program. In the accounting program, of course, we have quite a fair balance now between females and males. In the past, we used to have more girls, but now it's quite a good balance. I hope this answered the question from the audience. Okay. Let's looking at some more questions that come into Slido. This question deals with how heavy it is in this program. How many courses do I need to take per semester? Will I be able to survive this program? Perhaps again, Dr. Lim, you want to share a little bit in terms of this double degree, and then perhaps we have Kai-Jun to share his experience with another double degree program that also have lots of courses to take.
Yeah. Firstly, we have to admit that both degree programs are technically rigorous. As for the numbers of courses, typically it's about 5 to 6 courses per semester. As to whether you can survive, it's a matter of commitment and also interest in the subject matter. Because as Prof. Tong actually mentioned, and actually I'm also a case in point, when I joined accountancy program more than 30 years ago, my interest was in maths, and then I chose accountancy. So in a way, there is a synergy between the 2 degree programs because your interest in maths will also help you to do well in the DSAI program. And also in accounting, it's also about dealing with numbers, although we also require you to look at the accounting standards and so on. So there's also some language skills required. So the faculty here, we will guide you along, but it requires commitment and hard work on your part.
Kai-Jun?
Oh, okay. Yeah, I can share more about accounting and double degree in business analytics. To be honest, it's not as bad as you would think. I wouldn't say it's easy. Again, like Prof said, you need commitment, you need hard work, but it's really very viable. So I crammed almost all of my modules into the first 3 years. In the past 1 year, I've only taken 3 modules. In context, that's half a semester load over my last 1 year in school. So it's definitely very viable to finish it in the duration given to you. In fact, you can probably finish faster if you wanted to. For my double degree again, not for accounting and DSAI, but for my double degree, you can probably finish in 3.5 years quite easily. So I wouldn't say that it's a cakewalk, it's easy, but I would say that it's not as difficult as you might think. A lot of people think, oh, double degree, that's a lot of modules, must be really hard, you must work really hard. Not really. You have to put in the effort, yes, but at the end, it's really not as hard as you might think. There's a lot of guidance from faculty, like Prof said. Like I said earlier, some of the accounting modules are structured really well. It's not, they will guide you along the way, and it's not as difficult to pick up as you might think. So I would say don't be intimidated by the perceived difficulty of a double degree. I think take it as a challenge. It's something that you might have to stretch yourself. You might have to work a little bit harder, but it's not all that hard, and you can definitely do it.
Right, thank you. So, just to point out that Kai-Jun, although he's in a double degree program, actually have many opportunities in terms of exchange, in terms of internships. One question here is, how do you get those internships, Kai-Jun? Where are your sources? They go into all these fabulous companies that you intern at. Yeah.
Okay, this is an interesting question. Very loosely speaking, there are 3 ways to source for internships. The first one is through the school. The school, that breaks down into career affairs, it breaks down into career portal, etc., etc. The second way to find internships is through warm connections or co-connections. So this is through your seniors, the people you know, LinkedIn, whatever. Form connections with people, ask people out for coffee chats. Say, hey, look, I'm really interested in your job. I'm really interested in what you do. You spend like 20 minutes, I'll buy you a coffee, I'll listen about your job. Right? That's the second way that you can form connections that help you get internships. And the third way is just to knock on the front door, right? Just go door to door in the company, knock and say, hey, I like this company, here's my CV, please hire me. So 3 ways for you to find internships. I think that the best way is to either rely on the school or to rely on warm connections. So I think there's a statistic for this, but the majority of roles are actually filled by referrals. And the reason is this, right? If you're a hiring manager, do you want to look at 100 CVs of different qualities, you don't know what you're going to get, and you just open it up to the public? Or are you just going to listen to your few friends who say, hey, look, I have a really quality guy, and you should hire him? So the majority of hiring managers tend to rely on referrals. So I would say that if you're looking for an internship, your best shot is through a referral, your best shot is through a warm connection, or if failing that, a cold LinkedIn connection. So these are the best ways, I think, they can find an internship. But that being said, right, I think I'm talking mostly to the returning NS men, right? They haven't started university, right?
Yes, not all of that. We do have some girls that are coming in this year. Not
Okay, cool.
NS men.
Yeah, so don't be too worried about this. I know it sounds very foreign. It sounds like, okay, look, I have to coffee chat people. It's really difficult, apply for jobs, yada, yada. It's really not that hard, okay? After you come to school, the seniors will guide you. You can learn from what the seniors have done. You can see which companies they've been to. You can look on LinkedIn to see if this is your the career trajectory that you want, where have people gone to get there, right? So you really pick it up along the way. Don't be too worried. Don't be too intimidated by like this deluge of data. You will get there. No stress at all, right? So don't worry about it.
So thank you, Kai-Jun. And just want to stress the point that the schools will also have a career office to help our students find internships, good ones as well. In fact, Vincent also had a couple of internships under his belt. Perhaps we quickly share, how do you get those internships?
Okay, yeah. So for me, actually, in my second year, in the DSA program, we have the work-study degree program. So I was part of that, and the career office helped to source for different companies to take part in this program. And I was fortunate enough to have an internship with AMD, where I do a bit of data engineering. And actually, AMD has partnership with SCSE as well. They actually came down to teach some of our lab sessions. So they actually know our class and they know the people in our class. So that is how I got an internship with AMD. And then my current internship with Shopee, there was a competition which is on Shopee Code League. My team actually did pretty well for some of the contests. So it was a series of 8 competitions. I did well in mainly the data science competitions, and that's how I got a data science internship with Shopee as well. So I guess through these experiences, meeting people, participate in competitions, and building a portfolio, I think that will really help with getting the internship for you.
Right, thank you, Vincent. Very interesting question here. It says, if I read the double degree, at the end of it, do I need to choose to specialize in accounting or in DSAI? And also the same question as, I heard that I really need a doctorate in data science to do well, and an undergraduate degree is not enough. So perhaps Dr. Suref, you want to share a little bit on insights into this question?
Sure. So maybe the second one, right? That's more up my alley. Yes. So whether you need a doctorate, it's a good question, but let's put it in this context. The doctorates, there are lots of PhDs in machine learning and AI who are in the industry. It's true. But where are they in most of the cases? Either the doctorates or the PhD guys in this data science and AI field would end up in academia, back again, would teach and be researchers, or they would generally be in most of the research labs. So yes, of course, if you want to go with, say, Google, DeepMind, if you want to go with Facebook or Amazon or Microsoft in the research wing, then for sure, you would probably be expected to have a PhD degree. But how about in the domain of business? How about in the domain of regular production, in regular software, in regular development, where data science is becoming a part and parcel of the game almost every day? In those areas, you do not require a PhD. A PhD is too specialized. So going along with what Kaijing said, what Dr. Lim said, it's about the depth, right? If you are a PhD scholar in this field, you would not be an ML or an AI person. You would more likely be a computer vision person who does a specific part of computer vision. That's too narrow and too specialized. So it's much better to hire somebody in a business who has a broader outlook to this field and knows machine learning and AI, but not to that depth. So bachelor's and master's would be sufficient for your regular jobs everywhere. And believe me, if you look at this as a pyramid structure, that would be the generic tier. That's the broadest tier. So when we say we need so many data scientists and so many machine learning and AI people, we actually mean we need so many at the bachelor's or the master's level, not really at the PhD level. So that's my opinion in general, yeah.
Thank you. Dr. Lim, you want to?
Okay, so for the first question about specialization, by definition, once a student has fulfilled the requirements for a double degree in accountancy and data science AI, the student basically has both degrees. So the student can choose to go the accountancy path, to be, say, head of audit, and in audit to also head, say, data management, data and analytics within a Big Four, for example. Or the person can actually choose to join a tech firm, and a tech firm that is developing some accounting systems or business systems, and the person can be working in that field. So basically, if you talk about specialization, in a way, the person, the student in a double degree has specialized in both areas. So the person can actually venture into both fields and be on the same, be on par, I would say, in the same capacity as any accountancy graduate or any DSAI graduate. Basically, the person can venture into either of the fields or the intersection of both fields.
Right. In fact, this is the attractive part of a double degree. Right? So basically, you are trained in both disciplines, and you can excel in both disciplines and choose to specialize in either one, or be abridged between both disciplines in any organizations. But very quickly, the question asks, how can I become a certified accountant once I graduate from this double degree program?
Okay, so the student with a double degree basically has the degree from accountancy degree, just like any accountancy students, accountancy graduates. So the graduate will still have to go through the same professional exams, the same set of professional requirements to be, say, chartered accountant. Now we call it Chartered Accountant of Singapore. So there are some professional exams that all accountancy graduates have to fulfill, and also a certain number of years of work experience, just like any accountancy graduate.
Right, thank you. Let's turn to the two students here. The question is, what kind of student clubs are there that I can be involved in? Perhaps very quickly, both of you like to share some of the student activities that's available on campus. Vincent, you can mind?
Yeah. All right, so on campus, I think there are lots of clubs that you can participate in, from performing arts to, let's say, the student union. And personally for me, I'm in my school club, so I'm part of the School of Computer Science and Engineering Club. I'm in the academic committee. So basically in this club, we try to improve the welfare of students and try to make the students more bonded and be more engaged with what's happening in the school. As part of the academic committee, so I do things like managing the school's past paper solutions, and then organizing workshops that could potentially be useful for students. And there are other things as well, like orientation, dinner and dance for after graduation. And so generally in this school club, we organize activities that would help to improve the welfare of students, and that could be something that you want to do if you join NTU. But there are other things as well, as I said previously, like performing arts, let's say, if you're interested. Or there are even clubs like CAT Management Club, I heard. So there are a variety of clubs that you can join in. As long as you have an interest, I think there will be something for you. Yeah.
Thank you. Kaijin?
Okay, I'm going to do two things. I'm going to give a rough layout of what the club landscape looks like. And I'm going to talk a little bit about some of the clubs I've been involved in. So the first one, about the landscape. There are three main varieties of clubs. One is the NTU level club. So this tends to be interest area specific. Dance, cultural activities club, right? For example, dance, performance, etc. Student union, so on and so forth. So these tend to be focused around interest areas. Now the second type are your school clubs. So this tends to be focused around what the school does. So for business and NBS, right? This is business and accounting related clubs. Some of the clubs that we have is the audit and assurance club. We have investment banking club. We have marketing, which focuses on marketing, business and analytics club, and so on and so forth. So school clubs tend to focus on what the school does. So I think for the computing science school, it would be more of computer science related stuff, right? Now the third variety of clubs is a hall club. So in hall, you have various hall activities, like you can have hall dance, hall basketball, etc. So this tends to be related to the hall that you're staying in. So it's a little bit different from school and NTU level clubs. So for me, I've been in a couple of clubs. I've been in student union. I've also been in business solutions, which is a school club. So I think I'll talk a little bit more about business solutions. So I was involved from year 1 to year 2. So what we do is we train students to represent NBS overseas in competitions. So that's kind of how I got all the overseas trips to represent NTU in different countries around the world. So we train our students for a year. Then after that, we send them overseas for competitions in different countries. We've been to quite a few places. I think Canada, America, Belgrade. Belgrade is Serbia, I think. We've been to Thailand, Japan, quite a number of countries, right? So mainly what we do is we train students and then we send them overseas for competitions. And we also build our own alumni network to let them talk to seniors out there in different industries and understand what it is those seniors do, so they understand the job scope. It also helps them build connections, which then again goes back to the internship question, right? How do you find internships? So school clubs are a great way for you to build connections, and that's something that I saw in business solutions. So that's a little bit about my experience of school clubs.
Right, thank you, Kaijin. And in fact, for this first batch of double degree program student, you can actually take the initiative to start your own club, right? A club that is for you only, right? Because you're the first batch, pioneer batch of double degree in accountancy and data science and AI. So take the initiative, start your own club, and build your own team, right? Okay, one quick question for Dr. Lim. The question here is, what's the tuition fee that I'll be paying if I take on this double degree program? Will it be the accounting tuition fee or the DSAI tuition fee?
It will be based on the DSAI tuition fee. So that will be for 4.5 years if you complete within 4.5 years. So every year you will be paying based on the DSAI tuition fees. So in a way, you are getting double degree, but for the first 3 years, in a sense, you are paying less than what you would have paid for accountancy degree program.
Right, thank you. Next two questions, I think I can quickly answer this. How do I change my current single degree offer into this double degree program? Well, you can go and send an email to the Office of Admission. The email address is on the YouTube website. And send in your request to change if you are really interested in this new double degree, and send in soon by acceptance date, which I think is on May the 24th. So do it quickly if you are interested in switching. And another related question is, if I switch and if I already have an offer of a Nanyang scholarship, what happens to the scholarship? Well, if you've already been accepted into the accounting program or the DSI AI program with scholarship, the scholarship will follow you once you switch into the double degree program, right? So we're getting close to the end of this Q&A session. So let me close this session by asking each of the panelists to share very quickly 1-2 minutes on why would you recommend someone to take up this double degree in accountancy and DSAI in NTU. So perhaps we have Dr. Surev to start off.
Sure. Thank you, Prof. Tong. So for you who are coming into uni, my recommendation is based on what I have done myself. I would highly recommend going as interdisciplinary as possible, as early as possible in your career. It really helps you getting a very broad outlook on the entire industry, sometimes across industries, and try to see how things come together. As you go deeper into the industry and become more and more senior, you do not know where you will end up in 15 years, 20 years down the line, and how the industry will evolve in 15 or 20 years down the line. So I come from 3 different programs. My undergrad is EEE, my master's is math, my PhD is computer science. I am from cybersecurity, I teach blockchain, and I also, of course, teach data science and analytics. So this interdisciplinary outlook really helped me personally along the way. I kind of see how all these fields connect. Unfortunately, I don't have a background in business or accountancy or finance. I would love to have that. I would love if I had the opportunity. You have it. You have the opportunity of going multidisciplinary so early in your career and still getting 2 different specializations. One accountancy, other one DS and AI. Go for it.
Thank you. Vincent?
Yeah, okay. I think what the industry is looking for today is not just people who are good in their technical skills, but also in their domain knowledge. You need to know the domain that you're applying in. And I think accountancy is a very fast-growing field, and there are lots of opportunities that you can explore. So I think this is where the double degree program comes in. You will be very good at the technical skills through the DSAI part, and you'll also master the domain using the accountancy that you'll get from this program. And you can do this in 4.5 years, which is just half a year more than my DSAI program. So unfortunately, it wasn't offered during my time, but now you have this opportunity. You consider yourself lucky to have it offered during this year. So I highly recommend this course to you.
Thank you, Vincent. Dr. Lim?
Yeah, the evidence that together we presented to you on the immense job opportunities are really just the tip of the iceberg. You can Google search yourself and really look up. It's really a fast-growing area, fast-changing area for the accountancy field and established field, which is also going through a lot of changes. Accountancy gives you a window into the business. Accountancy is looking at structured data, structured transactions, whereas the data science AI is looking at unstructured data. So combining both actually allows you to manage data as a whole, and that is really a big field, a big playing field for you. So really, the field is just taking off, and this is the right time for you to take this up because you're not joining the workforce immediately. So after 4.5 years, basically that would be the right time for you to join the workforce because After 10 years, the field will be more crowded and you will lose the first mover advantage. This is actually a first mover advantage for you. And I really hope that you will exercise this option and not let it lapse.
Right. Thank you, Dr. Lim. Hai-Jin?
Well, I think it's always a cost-benefit analysis, right? I think the benefits are clear. Interdisciplinary studies, this is something that the market demands, right? You have all this qualitative information about this is where the market is going, people want technical expertise and domain knowledge. But more than that, right, there are financial incentives, and it's clear from the numbers that the market does value this stuff. So if nothing else, the financial incentives do speak to me. And I mean, the benefits are very clear at this point. I think some things that we can talk about is the cost. And regarding the cost of it, I think that I have three things to say, right? The first one is about how difficult it is. And I can't speak for DSAI, I can speak for accounting and business analytics. It really isn't that hard, okay? It's something you have to put in a lot of effort to make it work, yes, but it's not something that will kill you, it's absolutely doable. So don't be too worried about difficulty. Now the second thing I want to talk about is the 4.5 years. So some people say, okay, half a year, it's additional up cost, half a year salary, etc. But honestly, school is great. Okay, if I could extend half a year and stay here for another half a year, I would do it. So don't worry too much about the extra half a year. It's going to be great fun. You're not going to lose out that much compared to your peers. The extra duration is not actually really a cost, as far as I'm concerned, right? And the last thing is, I just want to emphasize that university is kind of a sandbox, right? Failing in university really isn't that costly compared to your career. So this is a place where you should try everything. You should stretch yourself, push yourself to the absolute limits. Do everything that's interesting that you can think of. Because failure in university really isn't that costly, right? So this is something that I think that rings true to me personally. And I think that the double degree in DSAI and accounting would be something I would really take if I was back in year one, right? Because stretching yourself, learning in university where failure is not costly at all, is something that you should really do. And so to me, right, I think the benefits are substantial and they're clear. And I think the costs really aren't as significant as people make them out to be. And to me, I think this would be a great program that I would really consider doing if I was back in year one.
All right, thank you. Dr. Suresh, Vincent, Dr. Lim, and Hai-Jin. I think all four of you make a very strong case of why you should choose this double degree program. Not only are you picking up skills that will put you at an advantage going into the new economy, but also really put you in preparation for doing good works, right? With the skills that you have, you're going to acquire from this double degree program. So thank you. I would also like to thank the audience for their attention and participation. We hope you indeed now have a better insight into this double degree program. And we also look forward to having you on campus in August at NTU. So thank you, have a good weekend, and goodbye.